Hi everyone, welcome back to this channel, and in this particular video I will be explaining problem D, that is peaks in array from Leetcode weekly contest 402. Okay, so first of all let's try to understand the problem statement, then we will see how we can solve this. So what problem says is a peak in an array is an element that is greater than its previous element as well as than its next element. Okay, so basically they have given the definition of the peak here, which element can be considered as a peak element. Okay, that has been mentioned here. After that, what they're saying is you are given an 2D array that is named as queries. And what are the queries? Queries are of two types, type 1 and type 2. If the query is of type 1, then we have been given two things, left and right, means a range. Okay, and we have to find the number of peaks in that particular range, both points inclusive. Okay, and if the query is of type 2, then what we have to do is we have to update the value at this index to this value. Okay, basically what we have to do is we have to overwrite the value at this index, whatever written at this particular index, we have to change that value and write this value to that index. Okay, and then we have to return a vector which will be consisting of all the answers for type 1 queries. I hope it is clear to everyone that what the problem statement is asking from us. Okay, now let's talk about how we can solve this, guys. First of all, let's try to understand the brute force approach. What can be the brute force approach? Okay, so in order to implement the brute force approach, what we will do is we will start traversing the queries and process each query naively. Okay, what does it mean? It means that let's suppose this is the test case. This is basically the test case 2 from the given samples. We will start processing our queries. Here, the first query is of type 2, and if you remember, type 2 query means we have to update the value on second index to this value. Okay, this is the index and this is the value. Means on second index means 0, 1 and 2. At this index we have to change this value to 4. Okay, second index, change the value to 4. This query has been processed. Okay, and let's also maintain our answer vector in which I'll be storing answer for type 1 queries. Okay, now second query is of type 1. Type 1 query says that find the number of peaks in this range, means 0 to 2. 0 to 2, find the number of peaks. And also they have mentioned that boundary elements can never be peak elements. Okay, so remember this thing. Only this element can be our peak in this range. And is this a peak? No, this is not the peak element. Okay, so for this range answer will be 0. Fine. Now let's talk about other queries, how we can process those queries also. Fine. Now the next query is, this query has been processed. Next query is type 1 query and the range is 0 to 4. Means 0 to 0, 1, 2, 3 and 4. Okay, this is the range. No, okay, this is the range. Means for this range we have to count the number of peaks. So this element and this element can never be our peak. Okay, now we have to check for these three elements. Means for this range, these boundary elements can never be our peak. So we have to check for these three elements that whether they can be our peak or not. How many of those can be our peak? Is this a possible peak element? Okay, let's check. Left and right should be strictly smaller than this element. So this is not the case. So this can never be our peak. Is this a peak element? Okay, this is a peak element because the left one and right element both are strictly smaller than 4. Okay, 1 is also smaller than 4, 2 is also smaller than 4. So this can be our peak element. 1. Is this a peak element? No, this is not a peak element because left one is greater than this element. So only one peak element is there in the range 0 to 4. Okay, so we have processed all the queries and answer is 0 to 1. Okay, is the answer 0 to 1? 0, 1? Yes, 0, 1. Okay, I hope you are getting the problem statement and the dry run on this, that what the problem statement is saying. Okay, now this is the thing that we have to do. And first of all, I have mentioned that we will be doing it naively in brute force approach. What does it mean? Naively means, let's suppose the query is of type 2, then we will simply go to this index and update the value, change the value, means array of index equals to val. Okay, this is the thing that we'll be doing for type 2 queries. And if type 1 query is there, then we will be traversing from left to right. You can also refer to the code here for more clarity. Okay, what I'm doing is I am iterating for all my queries, and if my query is of type 1, then what I'm doing, I'm saying that okay, give me the left and right range, which is x of 1 and x of 2, means second and third index will be the ranges. Fine. And now what I'm doing is I'm iterating from left plus 1 to right minus 1 because boundary elements can never be our peak, so we have to exclude them. And for this I have to check that whether left one and right one are strictly smaller than the current element or not. So this is what I'm doing here. And after counting all the peaks, I'm pushing all the peaks into my answer. This thing will be outside the loop. Okay, sorry for the mistake. This thing will be outside this loop. Okay, Otherwise, if type 2 query is there, then what I'm doing is I'm saying that, okay, this is the index and this is the val, just overwrite the value at that index to val. So this is all about brute force approach. And what will be the time complexity? Let's analyze that first. Time complexity will be for iterating over all the queries, means order of queue. Order of queue will be for traversing through all the queries, and for each query we will be traversing from left to right. Okay, and from left to right means in the worst case this can go up to n. So order of q cross order of n. Fine. This will be order of q cross n. Q is the number of queries and n is the length of the array. Is this acceptable? Let's try to focus on constraints and try to figure out is it acceptable or not. So the length of the array is up to 10 to the power 5. Okay, and queries length is up to 10 to the power 5. Means overall time complexity will be order of 10 to the power 10 approx. Fine, order of 10 to the power 10 approx. This is not exact but approx. So obviously this is going to be TLE. Okay, because this will be considered as order of n square approach. In standard language, which we will say order of n square approach, this is not acceptable because this will go beyond time limit. Okay, fine. So now let's talk about optimal approach, how we can solve this optimally. For that, there are some prerequisites that you should know. Fine. Let me mention that also. For optimal approach, guys, the prerequisite is you should be familiar with segment tree or binary index tree, that is also known as 1D Fenwick tree. Okay, and if you're not familiar with the segment tree, then you can watch the videos, okay, from any YouTube channel. You can also refer to the you can also refer to my videos. Okay. Here is the playlist for segment trees where I have explained all the things related to segment trees. Okay, how segment tree is built. Okay, what is the time complexity, how to build the segment tree. Okay, in the second thing I have explained in the detail like how to update the values, and in the next video I'll be explaining how to query the values. And if you once you are familiar with this update function, then query is just a piece of cake for you. Okay, I hope you have understood the thing that what you have to do now. If you're not familiar with the segment tree, just watch these two videos only. Okay, after that come to this video and try to understand this problem. Fine. And those who are familiar with the segment tree, then I hope you have solved this problem during the contest. Fine. Let's try to understand the problem. Okay, now let's try to figure out how we can solve this problem using segment trees. Fine. What we want, guys, we want to find the number of peaks in a given range in less than order of n time. Okay, in order of less than order of n time, because this thing we can't optimize. What are the things? Order of q is the time for processing through all the queries. This thing can't be optimized, and this was multiplied by order of n, which was the time taken for processing the ith query. So this thing we have to optimize. Means for a given range we have to find the number of peaks in less than order of n time. This is the thing that we have to do here. Okay, so segment tree will help us in doing so. Okay, and how? Let me explain. If you have watched the video for segment tree, then you have understood that each node of the segment tree stores the data for some partial range. Like here, this node is storing the data for the range 3 to 5. Means 3 to 5. This node will be storing the data for these three elements. This could be their sum, this could be the number of peaks in this range, this could be the XOR of this range, anything. It could be anything related to this range. Fine. So segment tree stores the data for any partial range. And here the data will be, also we have to define the data that what we are storing. Node of segment tree is storing now count of peaks in range left to right. Fine, left to right both inclusive, you can say. Fine, left to right. This is the thing that we will be storing in the segment tree. Fine. And how to build the segment tree, let me explain that also in a brief. First of all, we will using divide and conquer approach. Okay, I hope I'm just assuming that you know the basics of segment tree. Again, I'm repeating this so that you don't get confused with this, like why I'm starting with a leaf node only. Okay, with that, let's go and try to understand how we will building the segment tree. 0 to 0, this thing is saying, this is the smallest subproblem. This is saying that what are the number of peaks that are there in the range from 0 to 0. Okay, this is the thing that this particular node will be storing. So from 0 to 0, only one element is there. Means there is chance of having one peak element. But this is the extreme point. Means this is the left boundary point. So this can never be the peak. So this will be stored. There will be 0 at this index. Means from 0 to 0, there is no peak element. Fine. Next smallest subproblem is this node. This node is saying that I will be storing the number of peaks in the range from 1 to 1. means how many elements are there which can be the possible peaks in the range from 1 to 1. There is only one element in the range from 1 to 1. Okay, so can this element be our peak? We have to just check that, and based on that we have to place here 1 or 0, because there is only one element, so answer will be either 0 or 1. Okay, so is this a peak element? Left one and right one, both should be strictly smaller than this element, and that is not the case here. So answer for this node is also 0. Now this node is saying that I'll be showing the answer for 3 to 3, means how many elements are there in the range from 3 to 3 that are peak elements. From 3 to 3 means only one element is there. Oh sorry, I was considering this, but this is the element. So from 3 to 3, but still answer is correct for this. Okay, and for this also. So from 3 to 3 only one element is there, and this is also not a peak element because left one is greater than this. So answer for this node will also be 0. And for 2 to 2 means, can this be a peak element? Yes, this is a peak element because left one and right one, both neighbors are strictly smaller than this element. So answer for 2 to 2 is 1. I hope you are getting the point how we are building the segment tree. Okay, now this range is asking for 4 to 4. Is this element a peak element? No, this is not a peak element. 5 to 5, no. Boundary element, fine. Okay, now we have to conquer the things. Means first of all we have divided the problem. What was the problem? Problem was to count the number of peaks in complete range. Now we have divided this into two chunks, left half and right half. Then again we have divided the left half and right half. In this manner, first of all we have divided in order to get the smallest problem, smallest sub problem, and from those smaller sub problems we will be solving the bigger problems. How? This node is asking for 0 to 1, means for this range how many number of peak elements are there for from the range 0 to 1. Okay, and this node knows that the nodes below this has already been processed. Okay, means this node was divided into two halves, left and right, and this node will be storing the number of peaks in the basically what I'm trying to say is, let's suppose this is the range 0 to 1. Now this range has been divided into two parts, 0 to 1 means 0 to 0 and 1 to 1. Now this node is storing the answer for its left half, and this node is storing the answer for its right half. Don't you think so that if we merge these two, means if we add the number of peaks in the left half and right half, then eventually we'll be ending up having the number of peaks in the range, complete range 0 to 1. Okay, this is the thing that we are doing. And to solve left half and right half, we'll be using order of one time because this has been already calculated here. So in the left half there is 0 number of peaks, and on the right half there is 0 number of peaks. So total number of peaks from 0 to 1 will be 0. Similarly, for 0 to 2, 0 to 2 was divided into two parts, left half and right half. Okay, and this node is storing the answer for left half, and this node is storing the answer for right half. Don't you think so that if we merge these two, if we sum up the answer from the left node and right node, then we will be having the total number of peaks in the range 0 to 2. Now the number of peaks in the left half will be 0, and number of peaks in the right half will be 1. So total number of peaks in 0 to 2 will be 1. In this manner segment tree is built, 0, then 0, then 1. Now let's try to cross check that are the things going right or not. From 0 to 2 there is one peak. 0 to 2 means 0 to 2 there is a one peak. Is this the case? Is there a peak in 0 to 2? Yes, this one is an element that is a peak element. Okay, the only thing that we have to calculate is number of peaks in the given range. Fine. From 3 to 5 there is no peak element, this is saying. Okay, from 3 to 5 there is no peak element. 2 is not a peak element, 1 is also not, 5 is also not. So okay, segment tree has been built. This is the only thing that we have to do. Now the only part remaining is query, and for query you have to refer the videos for segment tree, like how to query the things. Because if the data has been stored in the segment tree, then querying is just a standard process to do. Okay, main thing is what to store and how to store, and that I have explained here. Now the query part is a standard thing that you can understand by watching some videos on YouTube. Okay, so this was all about this problem. This is how we have to build the segment tree, and what will be the time complexity. To build the segment tree, it will take order of I think 2n time. Okay, order of 2n time. I have explained this in a very detailed manner in the first lecture. Building will take order of n time. Okay, and querying will take order of log n time. Order of n for building, so we will pre-process the things. Okay, and update. The second thing is update, because the update queries are also there. If type 2 query is there, then we have to update the value on any particular index. So update, I have also explained the update thing in very detail here. Okay, you can refer to this video. I will attach the link for these two videos in the description box. Okay, you can refer to these videos from there. Fine. Now update will take order of log n time, order of log n time. Fine. And similarly, query will also take a login time. So the problem has been solved. What we wanted, the requirement was to solve the means to query the count of peaks in the L to R range in less than order of n time. And as you can see here that we are calculating the things in order of login time. So the things have been sorted and problem is solved, optimized. I hope you have understood the problem statement as well as the approach. Now let me explain the problem. Let me explain the code part. This is just the template of the segment tree. Okay, here what I'm storing the each node is storing basically sum. Okay, leaf node is storing the values that is this a peak element or not, and if this is a peak element then you have to just combine the complete values for the bigger ranges. So for that reason we are just storing the sum here. Okay, combine is a thing that to combine two nodes, like this node and this node will be combined as summation of this will be stored here. This is the thing that I'm doing here. Now in the build function, if we are at leaf node, this is denoting the leaf node. If we are at leaf node, then if that element is a leaf node, then place 1, otherwise place 0, and is peak is this function. This function is denoting that is the element at ith index in this array is a peak element or not. So that element should not be a boundary element and is strictly greater than both the neighbors, then that will be considered as peak element. This is what I'm doing here. Okay, now everything is just standard segment tree. The only modification is if the leaf node is a peak element, then place 1 in the leaf node, otherwise place 0. Rest of the thing are very similar. And in the update thing also we have to do, after updating the value, is if the peak element is there, then place 1 at the leaf node and again conquer the things or modify the segment tree here. Fine. And query is just a standard thing. There is no modification in the query function. And rest of the things are just very standard, that here I have maintained an answer vector to store the answer, and here I have initialized my segment tree. Then I have processed all the queries. If query is of type 1, then what I'm doing is, if the range is less than 3, means in order to have a peak element, the range should be greater than or equals to 3. Okay, I hope you're getting those boundary elements can never be the peak. And in order to have a peak element, range should be greater than equals to 3. So in order to avoid the redundant calculation or to avoid the overflow, I have mentioned the condition here that if the range is less than 3, then just print push 0 into my answer vector and continue from here. Otherwise, if the range is greater than equals to 3, then query the number of peaks in the given range from left +1 to right -1 and push back all the peaks in the answer vector. And if the query is of type 2, then what we have to do? I have stored the index and value and just update the value in the array and modify the segment tree. Now you will ask that why you have used the loop here. Because see guys, what is happening is, if I am modifying this value in the array, then two values are also affected due to this, left one and right one. So what I'm doing, I'm starting a loop from index -1. If this is index, okay, ind, then ind -1 should also be modified and ind +1, because these are the two elements that will be affected due to modification of this element. Okay, and max of 1 I'm taking because if this is the second element, then first element should not be modified. Not exactly the modification is done in the array, but modification is done in the segment. Because if let's suppose this index is modified, okay, then all the nodes in which this particular node is also lying, that will also be affected. For that reason we are running an update function on this also and on the right neighbor also. I hope you have understood the problem statement as well as the code part. Okay, these are the simple things that we are doing, just a standard segment tree problem this was. Okay, and just return the answer. And although the problem is hard because there is use cases of some hard data structures like segment tree or fenwick tree, rest of the things are very standard. If you are familiar with the segment tree, then the problem was just a piece of cake for you. Okay, so this was all about problem D guys. Thank you for watching the video and stay tuned for the rest of the tutorials.